That's,
All right.
I was gonna wait and do that once I found out if it was working.
No worries.
Okay. I think we're now in business, so thanks for bearing with us. But I think we got everything in order now, so I'd like to ask Mitch to start off with any updates that he has.
Sure. Hey, everybody. I'm off video because I am both technically on vacation and also a little bit sick. But it was a big week in the legislature, kind of unexpectedly out of the blue. We didn't know it was coming, but Colin Curitan and I both testified twice with respect to the Forever Green Research Bill and the Continuous Living Cover Value Chain Development Fund bill. Once in the House Ag Committee, once in the Senate Ag Committee. The key background to understand is that very recently the governor and the leaders of the House and Senate, so not the Ag Committee leaders, but the Speaker of the House and the Majority Leader in the Senate, they all agreed to budget targets for every committee, and that's negotiated at the very highest levels. And the budget target for agriculture was quite a bit lower than what people expected. It is an increase, but not an increase that seems to be commensurate with other committees and with the size of the surplus. So I think it's fair to say that the agriculture community as a whole was taken aback, pretty upset, and worried about what that means for our ability to about what it means for our ability to support all the needs. That have been put before those committees. So, Forever Green and Continuous Living Cover Value Chain Development Fund are still doing pretty well. We have on the research side. So again, I'm going to step back for a second because this is separate from the Clean Water Fund money that we've been getting every 2 years for about 8 years. That money is separate and moving forward and looks really good. So this would be additional money coming out of the base budget for the ag committees. The research bill is in both. The research bill in both the House and the Senate includes base. Okay, that's super important. Base funding, which means that it's not just slated for this biennium, this 2-year period, but would continue into the next 2-year period, and by default, at least, continue into the next 2-year period beyond that, and until just keep continuing on until the legislature decides to revoke it. So that's really pretty darn secure funding, and that's what we need to put a solid floor under this initiative and keep moving forward and doing more, achieving more. So that is really, really exciting. It's not the dollar number that we asked for, but we realize with a lower target, that's a situation that we're in. The House bill also includes $1 million for a one-time allocation of $1 million for equipment and infrastructure investments, and the Senate bill does not. So we'll see where that ends up at the end of the day. But we've got a toehold there as well. And I don't know if Colin is on. If you're on, Colin, would you like to speak to the CLC value chain bill? I don't hear Colin, so just briefly, there's, let's say, between $1 million and $1.5 million for the value chain development bill in both houses, both the House and the Senate. The Senate includes base, so that would be ongoing funding going into the future. Also very, very exciting to keep supporting the entrepreneurs who are working with these crops. The House does not. So the next stage of the process is that the House and the Senate bills ultimately need to be exactly the same. So most likely there will be some kind of a conference committee where they have, both House members and senators working together to iron out the differences. And that will be when the final numbers are determined. Legislatures are unpredictable. A lot of stuff could happen between now and then. A lot of folks are pushing for there to be more money found for the ag budget, which obviously we would welcome, but that's out of our hands. So just started getting an echo. So if you just joined or unmuted, you might be the culprit there.
We know who the culprit was. It was fine.
Okay. Yeah, I think that's the main update. I don't know if anybody else want to chime in with additional thoughts or questions on the legislative front.
Mitch, this is Peter from FMR. You noted this already, but just to reiterate here and maybe expand a little, the targets are what the agriculture chairmen and chairwomen are dealing with. They don't get much say over that. That was basically came down from on high. The governor and the leaders in both House and Senate more or less unilaterally made those decisions. Suffice to say that basically the entire sustainable ag community and the food systems community are pretty angry. I think it's fair to say, and we are working behind the scenes to do what we can to raise that figure. It's relatively early in the legislative session to be at the point we're at, so there's some hope, but it's far from certain that we'll be getting a higher target. There are a lot of folks across the spectrum from environment and human health and human services who are also angling for what they see as a fairer slice of the pie. So I think, well, not to raise expectations, but we are working behind the scenes to see what we can do.
All right, thank you very much for their updates, and I'll just mention one other thing in terms of the legislative component. On April 5th, representatives, including the chairs, the Senate Ag and the House Ag committees will be on campus for a tour. The intent was to take them for a field tour, but it doesn't appear that's going to be the case. So we have a backup.
You don't have snowmobiles?
So the backup plan is to tour them through the greenhouses and then serve them lunch based on Forever Green food products, and serve them a little Crimson beer in 306 Borlaug Hall. So exciting time to have both of the committees on campus for about 2 hours on the 5th. So with that, now we'll get to today's presentation. Kevin Smith is the current leader, and he's been the leader of the barley breeding program for how many years? 15?
23.
Oh my God, 23 years. How time flies.
Mm-hmm.
For 23 years, and as most of you know, the barley breeding program here at the University of Minnesota is world famous. It's produced major varieties over the years, and I wanted to make sure that we had the opportunity for Kevin to give an update on the overall program, as well as an update on the winter barley component of the program. So, Kevin, I'll turn it over to you.
Great, thank you, Don. So, yeah, so what we have planned for today, well, I'll start by saying that I have a large team, and I probably have forgotten a few names on this list, but these are a lot of the folks who are working in one way or another on different aspects of winter barley, both as a crop and also as part of our breeding program. And we'll talk mostly about breeding, but a little bit about sort of the deployment of winter barley in a cropping system as well too. So a lot of people involved. The folks that I've highlighted in blue are our 4 people who will be speaking a little bit today about.
We can only see your first slide, not.
So you can only see the first slide?
Yeah, we can only.
Yeah, they're
see
not
the
advancing.
presentation mode, not in the presentation mode, and we can't see the second slide is not.
How come it's up here? It's working.
Yeah. Maybe just X out and reshare, sometimes that involves it.
Yeah.
Sometimes not.
Just stop it and reshare. So that's showing it up here. That's supposed to be sharing the screen.
You can click different screens you want to share. Let's see which screen is actually sharing.
Okay, so you can do this here.
So. Yeah,
I see it's sharing.
so it's not sharing the right screen.
Okay.
So I don't know if you can make that.
Stop share.
Yeah, you gotta pick pick a different screen to share.
So it should be.
One more
Should be-
gremlin is showing up
Yes.
today, so hang in there, we'll get it fixed.
Okay, that should be hot there.
There we go.
That works.
Very good.
One additional gremlin dead.
There's probably gonna be a few more too, so. Okay, so anyway, lots of folks involved. We've had funding from a variety of different sources, over the years to work on this. Including, from industry, through the American Malt and Barley Association, working with RAR, USDA grants for Evergreen, of course, and MDA. So the plan for this afternoon is I'm going to give sort of a very high level overview and a little bit of history of the breeding program, sort of how we came to winter barley breeding. And then you'll hear from Ahmad and John Hill about approaches that we've taken to the probably the single most important challenge we have for winter barley, which is improving winter survival. And so Ahmad will talk a little bit about the genetics work that we've been doing. And then John Hill, who was most recently a postdoc with me, but is now at USDA at Kansas State University, has joined us to talk a little bit about the project that he was doing as a postdoc the last year that he was here, looking for other ways to select for and try to improve winter hardiness in barley. And then Jason, who's in Jake Jungers' lab, will talk about an experiment that we have started to think about how we're going to deploy winter barley varieties now that we have at least one from our program out there. And then we'll finish up with Sienna talking a little bit about the Forever Green's commercialization effort with respect to winter barley and other crops as well. So that is the plan. So I want to give a little bit of background about barley in general and winter barley. So barley is a little bit different as a crop, particularly malting barley, because the identity of the variety is preserved throughout the food chain. So growers obviously produce certain varieties, but then those varieties are binned separately. They're sent to the malt house separately. The malt companies malt individual varieties separately, and then they may blend malted varieties to deliver to breweries. But that identity is preserved all the way through. And so what that means is there's always a relatively few number of varieties that are out there being used and contracted by the malting industry. So this is data from AMBA. I know you probably can't read the small text very well, but it's contract data that's collected by AMBA so that we know which varieties are being contracted across the growing region for barley. And so it's a really nice tool for breeders. It's nice to know which varieties are most popular amongst the brewing community and the malting brewing community. But the one thing I wanted to highlight on here is that the three little areas highlighted in yellow are the only winter malting barleys on this map. Now, 10 years ago, there would be no winter malting barleys on this map. And in fact, AMBA has an approved list of winter barley varieties, or barley varieties in general that they contract, and 10 years ago there would have been none on that list. So one change in the industry is that now there are winter barleys that are approved by AMBA. There are even a few that are contracted. AMBA as an organization, which is an organization of maltsters and brewers, they collect dues based on malt and beer produced, and they support research. That organization has been allocating more and more research dollars towards winter barley, in addition to the traditional spring barley that they fund. So there are some changes in industry that are moving towards possibly more important or more prominence of winter barley. Okay, so just sort of a little history of the Minnesota breeding program. It's over 100 years old, and for most of that history, it has focused on spring 6-row malting barley. You can see a lot of varieties that were released there over time. Since I began here, I've expanded that program for various reasons to include 2-row barley, and I'm not going to go into a lot of detail there, other than to say that there's been sort of a major industry shift from 6-row malting barley being produced in the Midwest towards 2-row, and also started a winter program when I became interested in the possibilities of developing barley varieties that could be fall sown and contribute to all of the things that we want to do as part of the Forever Green initiative in terms of creating continuous living cover. And then we started out with a 6-row project, and that was actually funded by a USDA cap project. It was actually a wheat and barley cap project where we carved out one of the objectives to sort of accelerate the development of winter malting barley using genomic selection. So that was part of that larger project that really kickstarted the program that we have here at the University of Minnesota now. This is just a little map of where we do trials, barley trials in general in the state. And then in a subset of those in red are the places where we have been doing winter barley trials over the past few years as our program has moved towards advanced trials and advanced testing in multiple locations. And obviously we're thinking the southern part of the state is probably going to be more important, and so we're focusing more of our effort there. Although we have put some trials up in Crookston and Rosso, and I'll actually show you some data from Crookston that's kind of interesting. So this is a slide that I've used in the past to kind of describe the breeding scheme, and you've probably seen lots of these breeder slides in other presentations, and I'm not really going to go into the details of this slide. It basically just shows you, how we make crosses and how we advance lines through the breeding program, gives you kind of an idea of the scale or the time frame in which that work carries out. But if you look at the bottom, particularly what it was labeled in this older slide called the current scheme, you see that there's several years of industry testing that's required before a variety will get sort of that approval by AMBA and be released. And basically, we're not going to release or publicly release varieties unless we know there's some industry acceptance. Otherwise, no seed producer is going to want to produce it. So that's one of the challenges that we face for malting barley. When we started looking at the possibility of using genomic selection, that's the scheme you see that's on the right. The major change that we made in our initial work with genomic selection was to shorten the breeding cycle. And that's really where most of the potential gain from selection over time comes from in programs that use genomic selection. So if you look at the scheme on the left, you'll see that we get to about year 3 or 4 before we identify superior parents in our breeding program and cycle them back up to the crossing block again. So that's a 3 or 4 year what we call breeding cycle. But what we did with genomic selection is we took individual F3 plants, isolated DNA, used our marker models to make predictions about the traits for those individual plants. And then we actually made crosses right away and cycled them back into the program. So it was essentially a one year cycle. So substantial improvement or increase. So we released this variety, MN Equinox last year, first winter barley to come out of the Minnesota program. And this is kind of a timeline of how that research unfolded for MN Equinox. And I thought it would be interesting to share it because it's got a fairly unique story in terms of a breeding line. So this was one of our first attempts at genomic selection. And so the line that actually became Equinox went through 2 rounds of genomic selection back in 2009, 2010. And then we advanced it through our normal trials, our PYT, our preliminary yield trial, IYT, which is an intermediate and an advanced trial, as we normally would for any of our breeding lines. We also included it in a national trial that I coordinate that has locations in usually 20 to 30 different locations across the US called the Winter Malting Barley Trial. So we had it in that trial for a couple of years. But during the time that we were developing it, other things were happening in the malting brewing industry. One thing was that there already wasn't a lot of interest in winter barley to begin with. And then there was this, I alluded to this before, there was this shift from 6-row to 2-row. Well, MN Equinox is a 6-row winter. So it was like the least interesting variety for the malting and brewing industry that they could think of. And so basically what that meant is that line just kind of sat on the back burner. It just sat there. We didn't really advance it. I put it in trials. We kept it in as a winter hardy check because it turns out it has quite good winter hardiness. And so we put it in a check in all of our trials. And then in 2020, we decided to give some seed to an organic producer in southern Minnesota who seemed interested in trying out winter barley. He grew it out. He was really impressed with how well it worked. Did it again a second year. And at the same time, he was talking with folks at Albert Lee Seeds, and Albert Lee Seeds, heard about it and they thought, well, this is really interesting. Why didn't you tell me about this line, that you have in your program, Kevin? And I said, well, I did actually about 4 years ago, and you weren't interested. So it just sat there. So then they became interested and eventually negotiated a non-exclusive license to produce and market that variety. So, I learned a couple of things from this process, and I think one of them is that you just have to get varieties out there and let people experiment with them and test them in the real world if you want any chance of them to sort of take hold. So I don't know that Equinox is going to be any big acreage, but there's seed out there, people can try it. We can start to work with these new cropping systems that use winter barley in them. And then interesting, the other little wrinkle is that I showed some data to RAR. So RAR is a large malt company in Shakopee, Minnesota. They are huge. They do commercial malting for large and small brewers alike. And I showed them some data. They said, well, maybe we'll test that. And so now in the next couple of months, they're going to be testing that in their technical center, which has a pilot malt facility and a pilot brewery that can do like 200 to 400 pound batches of barley into malt. So they're going to be testing it to see what sort of potential they have. So
Equinox may bring it all the way back.
You never know.
To
Back to
six
sixth
row-
row.
to six-year-old winner.
Well, there's a lot of new brewers that have come on unless they might not even know what sixth row is. It's a brand new kind of barley. Come on. Anyway, so that's the story of Equinox. So Equinox is, we were excited about it because it was one of the better lines in terms of winter hardiness, but here's the reality, it doesn't survive every winter. And this is kind of our historical gauge of what the potential of winter barley might be in Minnesota. If you look across, these are all the years that we tested it in St. Paul and the winter survival, and you can see that it's about half of the years in the last 10 years or so where it has survived to a point where you could probably harvest it and get a good yield. I put a little question mark by 2022, but my estimate is that it will be 100% survival given the kind of winter we had this year. And Jason is also hoping for that too, because we use that variety in his experiment. And if it doesn't survive the winter, then we can't really do a whole lot else with that experiment. Okay, so then just a little bit more data about Equinox. So the last winter, not this current winter, but the winter fall planting of 2021, I pulled up data from sites where we had differential survival. So the last couple of winters have been pretty mild, and a lot of trial locations, we did have a good 100% survival in our national trial. But I pulled up Crookston, St. Paul, and Meade, Nebraska, where there was all very good differential survival. And basically Equinox was at the top of those trials in every place. So among the varieties that are out there and available, it is really probably the most winter hardy. The varieties I have in bolded here are ones that are approved by the American Malt and Barley Association. So it does better than all of those. And interestingly, even at Crookston in 2021-22, we used a different scale, but it was survived quite well. Crookston, we had to till that trial up because most of the plots were dead, but we did get survival data out of that trial.
So the ones that are in the darker ink, are those 2-row?
So Flavia, Windmalt, and Endeavor are 2-row. Thoroughbred is actually a 6-row. So there's kind of a quirk in AMBA where if you're a member of that organization and you request something to be added to the list of varieties, they will allow it.
I see.
And there was thoroughbred came out of Virginia. And there was a malt company and a brewer that wanted to use it, and so they asked to edit it. It's actually a terrible malt. I don't think anybody else uses it. It's not it has a lot of undesirable characteristics. So, okay, so the last slide I'll show, and then I'll turn it over to the folks, is just some quality data, some current quality data that we have. And I won't go into a lot of detail here, but these are just some of the malting quality characteristics that we measure: beta-glucan, diastatic power, malt extract, FAN, and total protein. And then I kind of indicated, there's sort of two classes of brewers these days: adjunct brewers that use rice or corn as a carbohydrate source of the brewing. Those tended to be the big brewers like Anheuser-Busch. And then there's all malt brewers who use just malted barley in their brewing. And those are a lot of the craft brewers that are out there right now. So they both want low beta glucans. They both want low protein. They all want high malt extract, but they differ very much on the sort of enzymes, the diastatic power, and on the free amino nitrogen. So that's another complication in breeding. You have to kind of look toward which market are you looking towards. But what I'll point out just briefly, and we won't delve into the details of this, the data here, is that Equinox actually has not bad malt quality, has low protein, just like these 2-row winter types here. It actually had better extract, and that was always a thing with 6-row barleys, as they had low extract compared to 2 rows. That difference has really diminished over time. So that's one of the reasons that Raj said, well, we should take a look at it. And then these are lines that are second year. These would be just sort of our intermediate lines in our current program. These are all 2 rows, and they have some pretty desirable characteristics. They have much lower beta glucan, which is something that's really important to brewers these days. This one particularly has really good malt extract and low protein. So we have some things in our program that are in that sort of second year stage that have done reasonably well in the field and looking like they're going to do pretty well in the malt house as well.
In 2-row, what's the diversity for winter hardiness?
I would say that, so Brian Steffenson's group has been mostly involved in screening germplasm for winter hardiness from collections all over. And most of the things that are winter hardy are 6-row.
So, right.
Yeah. And I think it just happens to be that, and there are 6-row feed barleys, so they happen to come from parts of the world that are very cold and where the emphasis was really barley for feed.
Can you cross winter hardiness from 6 to 2?
Yes. Yeah.
It's all about it.
I mean, and the one thing that's kind of interesting about Equinox, and this is a little bit of a lead into the next presentation. So Ahmad will talk about sort of that diverse collection of barleys that have been screened for winter hardiness. Equinox, I'm writing up the plant registration paper on Equinox now, which forced me to go back and look at things that we were doing 12 years ago. But it doesn't have parents that are particularly winter hardy yet. It has material from Oregon State University, and Oregon is not known for their harsh winters. So to me, that's hopeful, since it's the best that's out there now, and we know there are lots of other sources of winter hardiness out there. So
How big is the adjunct versus all malt kind of market? Because it looks like your 30, 23, 22 would be good for the adjunct.
yeah, I mean, the adjunct market is bigger, but
That's good.
the all malt market is growing.
Okay.
And one thing about the all malt market is they use more malt per unit of beer. So even though they might have a smaller portion of beer sales per se, they actually use more malt, and so that's kind of a growing area. So we're trying to select the both.
Sorry, more malt in just raw terms?
Yes, 2
Not
to
just
3
portion.
times as much malt. So if you have a Budweiser, and you have sort of a IPA, really heavy IPA, it might have 3 times the amount of malt in it.
Sorry, just clarifying, you're talking per beer, not per, across the industry.
Per unit of beer. So you just use in that recipe, you're using like 3 times as much malt to make a barrel of beer as you would in a typical Budweiser lager type beer.
Great, thanks.
All right, so next up we have Ahmad, and he's gonna update us on some of the genetics of winter hardiness or low temperature tolerance. So I will advance slides. Ahmad, if you unmute and talk, I hope we can hear you unless we have more gremlins.
Can everyone hear me okay?
Can hear you.
Speak up a little bit.
Okay, sounds good. So I will talk briefly about some of the approaches we used to improve low temperature tolerance in barley. In the University of Minnesota, we published recently a project to perform genome-wide association mapping for low temperature tolerance in the Vavilov barley collection. The publication you can see in the right. This is coupled with a haplotype analysis that includes this population in addition to the population to the left, the CAP LTT panel. This was done independently between two different groups. So of course, there are lots of collaboration between the common collaborators between the two studies. Next slide. So some more information about the CAP panel and the VIR panel. So the CAP panel is composed of 882 accessions, breeding lines, and the VIR panel is composed of 267 accessions. Both were genotyped with the 9K iSelect ESA. So we're able to perform genetic analysis for both of them simultaneously. In terms of the phenotypes, the CAP LTT panel was evaluated in 3 trials, where the VIR panel was evaluated in 7 trials across northern United States. In terms of genetic diversity, the CAP panels originated from our barley breeding lines that were originated from 21 different barley breeding programs worldwide, where the VIR panel is germplasm collections that were originated from 35 different countries. In terms of winter survival range for the CAP panel, between 11 to 74%, whereas for the VIR panel, between 28 and 89%. The average winter survival for the CAP panel is 38%, and the VIR panel about 74%. Just a little bit of more information about the VIR panel is a part of a barley accessions that we received from the NI Vavilov Institute from Russia, more than 2,000 accessions. And then we evaluated them in Santopol during the winter season. It was very difficult winter on the plants, and only 12% survived, about 267 accessions that we worked with here. 108 from those 267 are from Russia, 32 are from Ukraine, and 23 are from Bulgaria. Next slide. This figures to show the phenotypic distribution for both the CAP panel and the VIR panel. And we had 2 common checks that were repeated several times in both panels, shown here on red, Decto and Charles. We can see that many lines from the CAP panel to the left survived better than Decto, but we have more frequency of better lines with better winter survival in the VIR panel. That results make sense because, as I mentioned, the Vavilov lines were selected from a bigger set. So those represents the one that showed good level of low temperature tolerance. Next slide. The genome-wide association mapping was performed by 2 different groups, but I combined them here in this Manhattan plot. The CAP panel is shown to the top, and the VIR panel is shown on the bottom. So we identified several marker trait associations in both panels. In the CAP panel, they identified 15 significant associations, and the VIR panel, we identified 12 associations with about 5 overlaps between. That includes the important gene for low temperature tolerance, FRH2 and chromosome 5H. Next slide. So this shows the FRH2 gene, which was the most significant marker for low temperature tolerance in the CAP panel. We also identified the exact same marker associated with LTT for FRH2 in the Vavilov panel. We couldn't identify some of the associations or known associations like FRH2, or I mean genes FRH1 or FH3 in the Vavilov panel because since those were selected from a bigger panel, the frequency of the favorable alleles will increase up to the fixation level of more than 90%. So that's why we didn't have enough power to detect QTL mapping, but they were fixed or nearly fixed in the population. Next slide. This is a haplotype analysis that for the FRH2 gene, using the 3 adjacent markers that tag the FRH2. Those 3 markers are shown in the blue color on the top. They cover about 177 kilo base pairs. The most significant marker for both studies, the one in the middle, at about 561.6 mega base pair. The CAP panel is more than 880 individuals. So of course we have more diversity. So that's why we had 5 different haplotype alleles across the 3 markers. In the Vavilov panel, on the bottom, we had 3 haplotype alleles. The good news is the most favorable haplotype allele, which is haplotype allele 5 in the CAP and haplotype allele 3 in the VIR, both agree with each other. They had the most favorable haplotype allele score, which is an estimation to the additive effect for this haplotype. And also, we have the frequency here in this table for those haplotypes. For example, this haplotype allele and haplotype allele 5 in the CAP panel occur about 88.4%. However, the haplotype, the favorable haplotype, the most favorable haplotype highlighted in the green color in the VIR panel, haplotype allele 3, occur in about 80.5%. Next slide. So we performed a meta-analysis for winter survival for all the associations that were identified in both the CAP panels and the VIR panels. And that allowed us to identify the most favorable haplotype alleles associated with low pressure tolerance and individuals carrying those alleles. Next slide. We use this information next to develop a multi-parent advanced generation intercross population or a magic population with a goal of integrating all the favorable alleles from the founder parents together. So there are major advantages for the magic population, but the most important ones are the rich allelic diversity, in addition to the integration of haplotype alleles from 8 founder parents into this population. Next slide. This table shows the 8 founder parents used to develop this magic population. Those accessions or lines or breeding lines, they have good to excellent winter survival. They have both winter and facultative growth habits. They have both a 2-row or 6-row. I selected those parents, so all of them carry the most the favorable allele at FRH2 in this population. So all of them have FRH2. So we have this already. And then most of them, except one, all of them except one, they carry the most favorable haplotype allele at the FRH1 gene. 3 of them carry the favorable haplotype allele at FRH3. In terms of number of favorable alleles, the VIR 13976, this is a Russian landrace, has 18 favorable haplotype alleles that were identified in both the CAP panel and the VIR panels. MOB 2301 carry 13 favorable haplotype alleles that were identified in both the CAP panel and the VIR panel. We have 2. So I selected the most winter type accession from the Vavilov and also the best facultative type from the Vavilov collection. The other parents were originated from Oregon State University and University of Nebraska, and the last one is KW Scala from KWS company. Many of, as I mentioned, many of the selected parents have also, maybe I did mention that some they have excellent multi-qualities, including those lines, advanced lines from the Oregon State University breeding program. Next slide. This figure shows the timetable for the development of the magic population, starting from the 2-way crosses that was done in the winter greenhouse of 2020 till we finished the 8-way crosses. in the winter greenhouse of 2022. We started to advance this population. We are now at the F4 stage, and the plants are growing now in the greenhouse. The harvested plants in this greenhouse will be grown, and all of them are facultative type. They will be grown in Crockston for seed increase next summer. And the first time to evaluate this population for low temperature tolerance will be in next fall, and this will be the F6 stage. Next slide. So we have total more than 790 F4 facultative recombinant emerald lines of this population so far. We're going to evaluate it for winter survival in several trials. In Minnesota, we're going to have it in Centerpool, Rosemount, and Crockston. In Nebraska, we're going to have it at Mead. And we're going to have the population evaluated for winter survival at Bozeman, Montana. I know, Kevin, that he received several requests for evaluating this population, but I'm not sure about the other locations or other trials that we will use, will evaluate this population for.
Yeah, we actually had requests from North Dakota and Alaska, believe it or not. So, and I think if I do a little bit more advertising, I'm sure we would find other folks who'd be more. There's a lot of interest in looking at winter barley, and so I think we can add at least 3 or 4 more locations to that. Which is important because you need to get the right kind of winter to be able to really get good data. Yeah,
right. Next slide. I will talk briefly about an efforts we're doing now to improve winter durum for Minnesota conditions, winter Minnesota conditions. And there is a more growing interest for winter durum because of the production problems of limited seeds, in addition to the drought conditions in northern Great Plains that affect the yield in a negative way. We have been, in the last few years, being active in evaluating several winter durum breeding lines from different groups, different panels and gene banks, including the durum panel, which also include accessions with the best durum quality available. Some also German durum lines with excellent quality and excellent winter survival. And also we are evaluating the global winter durum panel in Minnesota. We started the breeding program in 2016, and we have now F6 advanced breeding lines. The picture we can see here to the right was taken last year in mid-July. There are a couple of advantages of using winter durum winter cereals in general is that the plants can affected less by drought conditions. In addition to the early maturity, you can see the plants are ready to harvest in by mid-July. Many of the breeding lines that we have so far, they have ranged from 90, advanced lines, they have ranged from 90 to 100% winter survival. Yes, I'm done with this my presentation.
Okay, great, thanks, Ahmad. I think maybe we'll hold questions so we can get to other folks. And so we will next move to John Hill Price, who's gonna talk about an entirely different way of trying to identify and utilize potential mechanisms for improving your hardness.
Awesome, thanks, Kevin. So yeah, as Kevin mentioned, this is a summary of some work that I worked on as a postdoc with him. I'm not currently doing it anymore, so we're trying to write up the results, and then I'm hoping that work can be continued, but not by me. So we can go to the next slide. But the big idea is trying to find ways to select for winter hardiness besides growing the plants out in the field and seeing what survives and what doesn't. Ahmed kind of talked about one way, which is looking at genetic markers, but I wanted to look at another way, which is you can kind of think about as trait markers in a way. We've kind of already talked about this, that winters are inconsistent, field selection difficult. But another piece of the puzzle that I think we don't necessarily think about as much is that winter hardiness introduces a really serious bottleneck on the selection process. As Ahmed mentioned, they looked at 2,000 lines and maybe 12% of those survived. And those were lines that were winter lines from, fairly cold regions, right? So that's a lot of diversity that you're losing that could be really useful in the breeding process, but that doesn't kind of make that first really high. So if we can find traits that we can measure in ideally the greenhouse or in, you know, a spring field or whatever, that predict some amount of hardiness, and then select for them like we would any other trait like height, or select for, like we select for grain yield, that's a way that we can get more consistent selection in. We can select things without having to bank on them surviving winter in multiple locations, and we can use a lot of material, a lot of diverse material for breeding. So maybe you have two lines that neither one survives the winter, but if you cross them, you might get one that has a really good value for some of these traits of interest that lead to it being able to survive the winter. So that's kind of the big idea behind this. Next slide. So Walid's lab really kind of led some really good work on this. The trait that he and his postdoc looked at was metaxylon diameter. So if you look at a leaf tissue or like a barley leaf, you know, there's this mid-vein rib that kind of goes down the middle. You can picture any other grass blade if you're not familiar with barley. If you cross-section that and look at it under a microscope, which you see here, you'll see these two tubes. So these almost look like eyes. That's metaxylon, which is carrying water up and down the leaf tissue. And what Bishal, Walid's postdoc, found was that if you have narrower or more narrow metaxylon vessels, then that's correlated with higher winter survival. And the thought is maybe that's preventing water, ice crystals from propagating down the leaf into the growth point or the crown. There's kind of a couple of theories about why that might be, but the big idea is we know that we can measure this in the greenhouse when plants are not exposed to cold, and it's predictive of how that plant would survive the winter. Another known trait in barley is crown depth. So when you plant the barley seed, sometimes you get a little bit of growth, and then the crown, which is the point where all the meristematic tissue is, where growth is coming from, sometimes that sets itself a little higher in the soil, and sometimes it sets itself right wherever the seed is. The deeper that crown is set, the better the plants start surviving the winter. So these are two traits that we know about. My question was, one, can we find more traits that we can measure, and then that are maybe even easier to measure than metaxylon diameter, which, you know, you have to sit down, you have to cross-section a leaf, you have to look at it under a microscope, get measurements, not really conducive to very high phenotyping. And then crown depth, which anytime you have to dig, you're adding a lot of time. And then the other idea was to look at, is there variation for traits of interest in spring material? So is there variation for metaxylon diameter in spring material? Is there variation for crown depth in spring material? And then is there variation for these other traits in spring material? Next slide. So the way I did this was I looked at a set of barley lines, so about 10 spring barley lines, and then about 10 winter barley lines with no survival. So these have been grown in multiple locations, we had survival data, so we knew even within the pool of winter barley, you know, that this line survives better than that line. And then on top of this panel of barley, I expanded my search by looking at other grass species that are related to barley, to try to find if there were traits in common amongst these other species, which we knew all 5 to be more winter hardy than barley. So in addition to barley, I looked at winter wheat and winter rye, which we use as survival checks in Minnesota. These things almost always survive even when all the barley dies. And then perennial members of the barley genus Hordeum. Hordeum brachytherum, which is native to the Western US, Hordeum jubatum, which you can find in Minnesota, and then Hordeum brevicubulatum, which is from kind of Central Asia. These are pictures of some of these plants. The plants I measured were much younger than these plants in the photos. I measured at kind of the seedling stage, but these were just better individual plants, so they're used for illustrative purposes. And then on this panel, I measured a range of leaf and plant architecture traits. And then, like I said, I looked for traits that either varied within barley, kind of along that known gradient of winter survival, things that were different between spring and winter types, things that correlated with winter hardiness within the winter types, and then also look for patterns across species. Are there any traits that, for example, the level is consistently lower in all 5 of these species is in barley? That's not conclusive evidence that that's a indirect selection trait, but at least means, you know, the thing that we know that these 5 species have in common is survive the winter well. That at least means it's worth looking at in barley, seeing if we can find variation for that trait in barley, and does it correlate with hardiness down the road. Next slide. So as I first mentioned, looked at traits just comparing spring and winter barley. And within that pool, I found 4 traits that were significantly different between these winter and spring types, or 4 main traits, or a couple of others, I think. But my data showed, one, confirmed Bishal studies that yes, narrower metaxylem is associated with improved winter hardiness, showed that yes, deeper crowns are associated with winter hardiness. I also found that a narrower crown was associated with improved winter hardiness, and that trait was not correlated with depth. So that's kind of an additional crown trait that one could look at. And then interestingly, I found that, and this one I don't know what to make of, but I mentioned it because it's interesting, was I actually, in addition to cross-sectioning leaves and looking at the metaxylem, I did peels of the surface and looked at the stomata, kind of with the idea, and this was suggested by Walid, that maybe there's some relationship between metaxylem size and stomata size. I didn't find that. What I did find was that there's a lot of variation for how circular those stomata were, which is a predictor of openness. More circular means higher percentage of open stomata, less circular, more closed stomata, or more of the stomata are closed. So this was just one measurement at kind of ambient temperature and like well watered, but not oversaturated. And I found that winter types tended to have more significantly more round stomata or more open stomata. So once again, I don't know what to make of that. That might just be noise, but it's at least worth mentioning because it could be interesting to follow up on. Next slide. So then looking across species, I found a lot more traits that varied in a significant pattern, which makes sense, right? There's only so much variation that we see in barley. Kind of the idea behind this is maybe there are traits that contribute to winter hardiness, but haven't really been employed in barley. So this is where I was really hoping to find some richness. I found pretty consistent patterns of winter hardy species having narrower leaves and also just lower area leaves than winter barley, or than any barley species. I found that they had thinner mid-vein, so you just measure the external diameter of that mid-vein. I found that the stems or tillers were tended to be thinner. And then I also found actually the opposite pattern for stomata. So that winter hardy species tended to have more closed stomata. And this kind of, once again, it's hard to say anything because I'm not measuring this in cold temperatures. I'm not measuring it in drought environments. So it may mean nothing, but there is some evidence that like a lot of the same strategies that plants are using to avoid water loss in drought are the same things that they're using to keep from having desiccation related or desiccation injury related to cold. So there may be something there. And then finally, I found that the ratio of the leaf blade thickness to the leaf midvein thickness, that being lower, or in other words, you kind of have a flatter or less differentiation between the blade thickness and the midvein thickness, was actually even a better predictor of winter hardiness than either blade or midvein thickness alone. So those traits are pretty easy to measure with a caliper. Next slide. Another kind of sub question in this, and this was one I didn't explore as much, but it was kind of trying to lay the ground for future work, was looking at the perennial species Hordeum bulbosum, which is interfertile with barley. I forgot to mention those other perennial species or not. Looking at this potential source of winter hardiness. So there exists many or at least one good population of bulbosum crossed into spring barley lines. So you have a plant that's mostly a spring barley genome with part of one chromosome or part of a couple of chromosomes are derived from bulbosum. So I looked at just 6 of those. So we have a set of several hundred that we have seed for. But I just looked at 6 because that was what I happened to have, and found significant variation for this, a significant reduction in leaf midvein thickness in some of these lines compared to their spring parents. So whatever introgression that these lines have, they are contributing to an improvement for one of these indirect selection traits. It's just one trait. There was near significant reductions for several others. This 65F3 line was really, really interesting and showed a lot more of these indirect selection traits in the kind of favorable direction compared to its spring parent. So it seemed like whatever introgressions that line has is probably introducing a lot of this. It could be really interesting for winter barley breeding. But anyways, indicates that this population is probably at least worth looking at for indirect selection traits, and probably also worth exploring for winter hardiness.
Still there, John Hill?
Another next slide. Okay,
Oh, sorry.
so then just wrapping up, the kind of next steps in this project are one, to validate association between these best candidate traits and winter survival. One good candidate for this will be Ahmed's magic population. So measuring traits in the magic populations, how it corresponds to winter survival. Looking at a few of them kind of routinely in the breeding program could be really useful. And then also, Kevin and I have talked about developing kind of more targeted segregating populations that might help kind of understand some of the trait associations. It'd also be worth looking at variation in existing winter diversity panels like the LTT cat panel, as well as also existing spring material. Land races could be a really good source of variation for some of these traits. And then finally, it'd be worthwhile to phenotype a larger subset of the H12 some intergression lines, both for indirect selection traits and also putting them out in the field and seeing how they do would be fascinating. And that is all I've got.
Great. Well, thank you, John Hill. So I think, again, we'll just hold questions to the end and we'll move on to the next section, which is going to deal with what do we do with these great new winter barley varieties that we produce out of this program in other places.
Yeah, so I'm Jason. I work in the Jungers lab, and kind of looking at the agronomic aspects of winter barley. And so we wanted to think of a system where we could double crop this winter barley into. And so soybean was kind of the first that kind of fit with growing times and things like that. So I'll kind of explain that a little bit further as we go through the experimental design. So one of the things that we really wanted to focus on was nitrate leaching. And so having this quote unquote cover crop of winter barley being planted in the fall and then being in the ground for the spring is to see if that would reduce nitrate leaching. And so this was a meta-analysis conducted in 2018, where they had a bunch of different cases where they were looking at winter cover crops at reducing nitrate leaching. And so they found that non-legume species were about 50% reducing nitrate leaching, and then legumes and mixtures are a little bit unclear on that. But since we're dealing with a non-leguminous species, we think that this would be a good crop for reducing nitrate leaching. And we actually Kevin actually did a bit of a pilot study where they planted winter barley and they had 4 different treatments. I'm not certain what those winter barley treatments were, but then there's also a fallow field. And so soil samples were taken at the end of the winter barley growth, and we analyzed them for soil extractable nitrate. And you can see that the fallow plot has significantly more nitrogen in the soil compared to the winter barley, which we attributed to winter barley taking up that residual soil nitrogen. So this led us to form this experiment with our first research question being, does winter barley reduce soil nitrate leaching when there's no crops on the landscape? And then you can click twice more if you want. And then there's a fear among growers that some cover crops may reduce residual soil water for their summer crop. So we will look at that as well and analyze that data. And then lastly, we want to know what the best nitrogen rate application for winter barley is in terms of both yield and quality. As Kevin was saying, we want to make sure we have a lower protein content. So if we're adding a lot of nitrogen, we might increase that protein content. So we want to keep that low. And then also what the best row spacing for a short season soybean would be. So I'll kind of go into the experimental timeline a bit, but part of the issue with growing winter barley and soybean as a double crop is that we want to harvest the winter barley in about June, but May is when traditionally soybean is planted. So we think that we could probably do a short season variety of soy and hope to get decent yields with that. So for our experiment, we have 2 different controls. We'll leave a plot fallow, and then we're also going to test soybean row spacing. So we'll have a 30-inch row space, which is the more traditional, and then a narrow row of 15-inch row spacing. And And in these plots, we're planting long season soybeans at optimal N rates. So these will just be how you conventionally grow soybeans in the Midwest. And you can go to the next one. And these are experimental treatments. So we'll plant winter barley in the fall. And then we have 3 different nitrogen applications that'll be at the spring. A control of 0 pounds per acre, 50 pounds, and then 100 pounds. And then they'll be followed by the short season soybean at 2 different row spaces. And because they do have that shorter growing season, we're hoping that the narrow row space will allow for canopy closure quicker, limit weeds, and hopefully increase those yields as we are limiting the growing time. So the experimental timeline, in October of last year, we planted the winter barley. We have 3 different locations. There's one here on St. Paul, and then Waseca and Becker, Minnesota. And so we planted the winter barley at 7.5-inch row spaces using Equinox, and then we installed resin bags and lysimeters. Those will both be ways to measure the soil nitrogen or nitrate content. And then we'll also do some soil we did some soil sampling to get our starting soil nitrogen content. In April, hopefully, maybe we'll assess the winter barley survival. And then once we can get into the field, we can actually start taking lysimeter samples and getting that soil moisture data. And then in the May, in those fallow plots, the soybeans will get planted. And then June, we'll harvest our winter barley. Those resin bags that get installed in the field, so we will collect those and look at the nitrates that have been absorbed to the resin. And then we'll plant those short season soybeans right after we harvest the winter barley. And then we'll harvest all soybean plots in October and look at differences in yields on that. So this is a picture of our barley field in November here on campus. So I outlined a fallow plot in the top right. And then in the middle of each plot, we installed a lysimeter and a resin bag. So that's what that circle in the middle is. And so we have 4 replications of each of the 8 treatments that I outlined in those diagrams. And so we have a total of 32 plots at each location. And yeah, and so that's what we're looking at pre all of the snow. And so we're hoping we get some survival out of that. And you go to the next one. So this is how we're measuring nitrate leaching. So lysimeters, we're using cup lysimeters that go 24 inches deep into the soil. So that's that top left picture. And we can collect, as long as there's soil water, we can collect and pump out that soil water and get the concentration of the nitrates in that water. And so this allows us to know the concentration of nitrates through time. So we can take these samples every week during the growing season. But it doesn't tell us how much nitrate was leached out of the system. It's just a concentration of the nitrate in that water. So that's why we're combining this with resin bags, which is that bottom left. And so they're 3-inch by 3-inch bags that we drilled, as the picture on the right is. So we installed the resin bags about 20 inches deep. And the idea of both the 24-inch depth and 20-inch depth is that we're hoping that's below all annual crop roots. So any nitrates that we collect from those will be theoretically potentially to be leached into the groundwater. So the good thing about resin bags, while we can't harvest those out of the ground each week and look at how much nitrogen's there, it'll give us a cumulative total of nitrate that's absorbed. So in that timeline, we installed these right before planting, and then they'll get harvested with the winter barley. So then we can see how much nitrate was below the fallow plot versus a plot that had winter barley on it over that entire growing time. And then to answer that question of how much the cover crop or that the winter barley strips water from the soil, we're going to be using a PR2 profile probe, which is on that picture on the right. And it has 6 different depths that it gives you volumetric water content. So at 10, 20, 30, 40, 60, and 100 centimeter depths. And we haven't installed these yet, but they will get installed just next to those lysimeters in the center of each plot. And so it's a quick measurement. It'll tell you the volumetric water content and different units that you want. and we can go out and get these readings either bi-weekly, makes the most sense. And then in concert with the lysimeter, since we know the concentration of nitrate, we can and then the soil moisture probe will give us the volume of water. We can theoretically kind of get a total nitrogen loss from the system with those two together. And then also we will look at comparisons of soil water through time underneath the fallow plots and underneath the winter barley plots. And then these will stay in the field even with the soybeans that are growing through October. So we will know exactly how much water is in these plots and can answer that question of, does winter barley take up all of the water that soybeans might need in the summer? And that is all I have.
Great. Thank
So,
you, Jason.
so do you have a site where you have real soil? You know, the sand, and this is really, it's a, you know, a gravel pit. Here.
Mhm.
What's the other third side?
There's
Wasika.
Wasika,
Yeah, you're fine.
yeah.
They're very different.
They are, yeah.
Great, thanks. Well, we will move on to the last presentation of the group, and that is Sienna Nesser, and she's going to talk a little bit about commercialization efforts for winter barley and other crops as part of the Forever Green initiative.
Great, thanks everyone. Yeah, so I am working on the Forever Green commercialization team, and one of my main projects is called this ECO program, and Economic and Environmental Clusters of Opportunity, and it was developed by Forever Green and the Minnesota Department of Agriculture, and it's a way of supporting the folks who are growing some of the new Forever Green crops. So, and winter barley is one of those crops that is covered by this program. Some of the basics of what we're doing with the ECO program: we have a technical assistance team that includes growers, community members, and university professionals. You've all heard by now probably that we have a new agronomist on staff starting in a few days. He will also be part of that technical assistance work. Next, there are two types of payments that this program provides to growers. There's an ecosystem benefit payment that's field specific. We use the nutrient tracking tool to determine an estimate of nitrogen loss potential for each field. And then that payment is based on that number. So it's between 25 and 50 acres for perennial grain Kernza, and then 20 to 40 acres for winter annuals, including winter barley. And then in addition to that, there's an economic risk payment that's similar to crop insurance, but with no premium. And that kicks in if there is a market or crop failure, and that will cover about half the cost of production for the grower. So we've listed the example max payouts for hybrid winter rye, Kernza, and winter camelina. We're still working on getting exact numbers, but those are some ideas there. And then the last piece of this is we cover seed and grain testing, which has been really important for understanding what Kernza is doing out there, how the crop is doing, and it's a good way for us at the university to get back some information from growers, and it's also really useful for the growers. So those are some of the basics. And next slide. So this program started the payment program started in last year. The TA work, technical assistance work, started in 2021, I believe. And so we started out working just with Kernza, and now we have a second round of funding available to cover winter camelina, hybrid winter rye, and winter barley. So that's why I'm talking about this today. This round 2 program was launched in 2023. And the other change that happened is we've expanded what areas that we're covering. So this kind of a foundational idea to this program is that we're trying to promote kind of communities' capacity to develop these crops. And so that's why it's called these environmental and economic clusters of opportunity, is kind of trying to promote these crops in specific regions. So that's what this map is here, is showing the 4 different regions we're covering. So we started in round 1 with a goal of 1,000 to 1,500 acres of Kernza grown in this program by 2023. We are moving well towards that goal. Not quite sure if we're going to hit it or not, but and then this round 2 goal is to have 5,000 acres for all 4 crops by 2024. So that's the very basics. And I will stop there, and I think hopefully we'll have some time for questions, but happy to talk about this beyond this meeting as well. So thanks, everyone.
Thanks, Sienna. All right, well, sorry for going a little long there, but for those who've stuck around, we can open it up for other questions or comments.
Yeah, everything in chat.
People know that.
No. Yep, so it's wide open for any questions or comments for the team.
I have a quick question, I guess. I was thinking of another possible trade. I know Jake Jungers scans intermediate wheatgrass leaves with NIR, but I think it's only for like protein. But I don't know if you could scan them for fatty acid profile, because that might help with some winter hardiness. I don't know. I don't even know, but I'm just throwing it out there. But yeah.
Yeah, that's a. Oh.
Go ahead, Jenna.
I'd say that's a good thought. I've also looked a little bit about, can you use any kind of IR stuff for like water content, because that's important. Yeah, definitely a thing we'd think about. Yeah, sorry, well, I cut you off, Walid.
Have you looked at that or thought about leaf?
What's the question again?
Oh, yeah, I know, like, you can scan leaves, like, intermediate wheatgrass, they do it for protein, but what about fatty acid profile? I don't know if that's a thing or not, if it's something that can be done or not, can't be done.
And why specifically fatty acid?
Oh, just like, if it's higher in, or if there's variation for omega-3, that might help with winter hardiness or something.
And is there a connection, of a connection between omega-3 and?
Yeah, I think there is a connection. I think the more double bonds helps with, I know, providing more winter hard or just cold tolerance.
Oh, I see what, okay, that's different thing, but the idea is the assumption is interesting and has some, but I would say it's the lipid composition of the cellular grains, whether it's saturated or not.
Yeah.
That is an indicator of their ability to withstand those huge tensions that appear when there's ice nucleation or where you have ice crystals within the membrane. So that is a process that is happening. It's actually the process that takes place through hardening. So the progressive decrease in temperature induces changes in the lipidome, and that leads to kind of that change. I guess the question is how to high throughput phenotype for that.
Yeah.
Right.
Yeah, we want to just run through NIR and know like right away.
No, I think. So, but they're like
100 samples an hour.
That's the game.
But I think it's an interesting idea. We might, like, there might be ways to find proxy traits that capture that, maybe through lysing cells and extracting them. But yeah, I don't know. But it's definitely part of the winter hardiness, which is this change in
And the biochemistry, and there's this biophysical component to it.
Yeah, I have no idea, but I was curious if anyone's tried it, but yeah. That'd be, yeah, maybe not NIR, but if there's another way to hire throughput to it, that'd be cool.
What kind of survival rates and spread do you look for a good test winter?
Not everything being 100 and not everything being 0. A lot of times you get those, so. Probably in all of the different environments we screen things in, I would say easily half of the environments are not meaningful because either everything survived or almost everything died. So the last few winters have been great for people who are growing winter barley in Minnesota, but I haven't been able to find stuff better than Equinox just because Equinox is already 100, but I bet there are things in the program better. I just can't see them yet.
Have you looked at trying to do growth chamber stuff?
I had a student that did a little bit of that, and she was fairly frustrated with using growth chambers and the fact that they weren't terribly reproducible and fairly low throughput. But I don't know. I mean, we haven't done a lot with growth chambers, but that is a possibility. The group I've talked to at North Dakota State actually wants to screen these 2 panels that Ahmad talked about, or a subset of them, in a controlled freezing chamber. So we're going to send them seed this summer, and they're gonna do that.
That's one of the things that we had proposed in this legislative process was build infrastructure here on campus that gave us better capacity to do these types of evaluations on a wide range of species that we're trying to develop.
And I'll say the freezer that we do have, so I've run experiments through that before, and you can get I don't know, 150 lines probably, depending on how many reps you want. It's more of the it's like the capacity is important, but it's also having somebody able to take the time and have the space and everything to do the validation and running. You have to run a whole bunch of reps through there to figure out what parameters actually get you usable data, and that's almost more of an impediment, I would think, than the not saying we shouldn't buy stuff, but I'm just saying that's it's not as simple as just as you all know, it's not as simple as
but just so you know, in this proposal, it went beyond, just instrumentation. It was an investment in the capacity, including people to do that, right? So it wasn't just purchasing a piece of equipment. It had to do with the infrastructure, and for me, when I say infrastructure, it's the human part as well as the physical part of that type of investment.
That's probably the most valuable part, because a lot of these infrastructures are ad hoc. So for instance, when we think about doing an experiment where we impose freezing treatments, I don't think that the current growth chambers are reliable 100%. So you need someone to help develop those things as well.
Well, that was the intent of the request for the investment. So, any other comments or questions for those of you that hung with us all through the hour and a half? This is your chance to ask this group. We don't get them together except once a year. So this is your chance to.
That's what we hug all the time.
Well, that's
One shot.
Well, that's when we do it. Right? So.
Does barley always come out as 2-row or 6-row? What happens there?
I mean, there are, the heterozygotes have some of them have sort of an intermediate phenotype where, you get a partial filling of the lateral kernel, which normally would be sterile in a 2-row. But it's a single gene that controls the major morphological trait. Yeah.
Well, that's good.
But oddly enough, the breeding programs are totally different. So they're very different breeding populations, even though there's really just one gene. There's not a lot of crossing between 2 and 6. I mean, we do it, but it's not.
Yes, I know in walnuts, the trait for terminal bear for spur bearing is a single gene. The kind of trait you would think would be more complicated, but
yeah.
Are there any more comments or questions? Let me just make one. You guys are impressive. You guys are doing all great work. And I have this feeling that in 10 years, 5 years, that we're going to see a great advancement in both. Towards, I'm sure you're going dedicated to the 2-row, is that right?
Yes.
And.
Yeah, I'm encouraged by the commercial interest, so
Yeah.
we'll see if that holds out, because the state of Minnesota malts a lot of barley.
Yeah,
So,
exactly.
but it's one thing that makes winter barley a little bit different than some of the other crops is we know where the market is, and it's right here.
Yeah, exactly, yeah. Well, it's good to see all of the work that you've done to tie to the small brewers. And with RAR, I think, as you're saying, I think creates a great opportunity to move the outcomes of your program forward here in Minnesota as well as across the country. So congratulations on all the good work. So thanks to everyone online for sticking with us, and we'll see you next.